Right, electronegativity. It's the ability of an atom to attract electron density from a covalent bond, and it's that that little bit at the end is quite important as far as this is concerned. Now, the trends in on electronegativity. What you find is just trying to find a reasonably. There we go. A reasonable periodic table. Here we are. Is we tend to find that electronegativity increases across the period in the periodic table, and it increases up the periodic table. So therefore, fluorine tends to be described as the most electronegative element in the periodic table. The reason, of course, that the noble gases aren't considered to have any electronegativity is because of that bit from a covalent bond. Although I believe recent research has tried to determine the electronegativity of one of the or some of the lower elements in the group 18, and they come out to be very high indeed. But let's just take it as fluorine being the most electronegative element in the periodic table. So we tend to move in that direction for the increasing electronegativity. So how can we explain why we increase the electronegativity in this way? Well, one way of looking at it would be to say, well, what we're getting, of course, is as we go across a period, we're increasing the number of protons in the nucleus. The size of the atoms is going to decrease. Therefore, what we will find is that the nuclear attraction for the electron density between two atoms is going to increase as we go across the period from left to right. Similarly, what we can say is that as we go up a group in the periodic table, the size of the atoms decreases. Similar sort of shielding, I suppose you could say, because we'd have the shielding electrons would tend to balance out the extra nuclear charge on the atom. So each of the elements in one particular group will experience the same nuclear charge attracting to the outer shell electrons, but therefore, because the size decreases as you go up, then the attraction for electron density between two atoms would increase because of the smaller size.